All right, imagine a career path that's less like a corporate ladder and more like a chaotic game of pinball.
Okay.
You start your life as a physicist at Berkeley, and we're talking really high stakes deep tech stuff here.
Right, like laser fusion, superconducting materials, serious heavy-duty science.
Exactly. So you're spending your days just, falling down these scientific rabbit holes, but then, snap, you pivot.
A full 180.
A full 180. You leave the lab, you put on a suit, and you become a lawyer. All of a sudden, you're billing clients by the hour.
Obsessing over contracts, tracking your life in, what, 6-minute increments?
Yeah.
Sounds like a midlife crisis.
You would think. Or maybe two completely different people. But then, just when you think you've settled into that legal grind, you pivot again.
And this is the big one.
This is the big one. You co-found what ends up becoming, you could argue, the most critical open source AI company in the world.
And that trajectory, of course, belongs to Thomas Wolfe, the co-founder and chief science officer of Hugging Face.
It does. And today, we're not just, looking at his resume. We are unpacking a really dense, really fascinating conversation he had.
This was on the YC Root Access channel, right? Recorded at NeurIPS 2025.
Fresh from the conference floor in San Diego. So it really captures the state of the industry right now as we're looking at it from the lens of early 2025.
Which was a time when the AI landscape was just shifting incredibly fast.
It was. And the mission for this deep dive is, well, it's pretty specific. We want to move past the AI is cool hype. We want to really look at the philosophy of what he calls open science.
And the psychology behind building developer tools, because that's a huge part of this.
It is. And honestly, to get a reality check on the difference between a cool demo and an actual shippable product.
Yeah, Wolfe dropped some hard truths for builders in this one, particularly about this idea that distributing power, giving the tools away for free, actually catalyzes ecosystems.
Instead of destroying them, which is what you'd think.
Right, it's a very counterintuitive take in a world where everyone is trying to build a moat.
I love that. So let's start there with the man himself. Physics to law to AI. How does that combination even work? Law seems so far away from laser fusion.
It does, but Wolfe argues that this specific, zigzag path is the actual DNA of Hugging Face. It wasn't a mistake, it was the secret sauce.
Okay, so how does he break that down?
It's all about mindset. So when he was at Berkeley doing his PhD and postdoc, he was in pure science mode.
Which means what exactly? Just exploration.
Pure exploration. He talks about falling down rabbit holes. In physics, you might spend 48 hours straight on one tiny niche topic.
With no guarantee of any output at all.
Zero guarantee. You are digging for truth, not for ROI. It teaches you deep focus and, resilience.
Right. Failure is just part of the data. But then he becomes a lawyer.
And suddenly, time is not for exploring. Time is literal money. He mentioned billing at, $300 an hour?
That'll change your relationship with the clock real fast.
It completely rewired his brain. He said he realized that time is this finite resource you have to assign with brutal efficiency. You can't spend 2 days on a rabbit hole if a client is paying for a contract by noon.
So you have the deep, obsessive curiosity of a physicist who can understand these huge, complex systems.
But it's tempered by the ruthless efficiency of a corporate lawyer who knows the value of every single hour.
And that synthesis is Hugging Face.
That's the idea. And it's funny, he actually mentions that Hugging Face started as a gaming company.
I always forget that. Such a classic Silicon Valley pivot. We're making a Tamagotchi chatbot. No, wait, just kidding. We're revolutionizing global AI infrastructure.
Well, that pivot happened because Wolfe joined to explore deep learning for the game. He built a library to help himself, it went viral, and they realized, wait, the infrastructure is the actual product here.
But that lawyer mindset is why they survived. They knew how to allocate resources, not just do cool science projects that went nowhere. Okay, let's get into the philosophy, because this is where that open science debate gets really heated. Wolfe talks about catalyzing versus cannibalizing.
Very specific choice of words. And it really defines the split between the open source model and, the big closed proprietary labs.
He argues that the goal of open source is to distribute power, which sounds nice, it sounds very democratic, but is it a good business strategy?
Well, his argument is that when you distribute power, you catalyze the ecosystem. You make the whole pie grow faster for everyone.
And he contrasts this with the closed models.
Which he says try to cannibalize the ecosystem.
Meaning, I own the model, I own the users, I own the data, and you just rent access to it from me.
Right. It's a winner-take-all approach. But Wolfe points out that in scientific research, Progress is rarely about reinventing the wheel. It's about tweaking.
Okay, give us an example of that. Why is tweaking so important?
So he mentions positional embeddings.
Right, let's pause right there. Define that for us, but without needing a math degree.
Okay. Think of a large language model, like a giant library. Positional embeddings are the system that helps the model understand the order of the words.
So dog bites man is different from man bites dog.
Exactly. It's that core understanding of sequence. It's a specific part of the engine.
Got it. It's a component.
Now, imagine you have a brilliant idea to make that one little part 10% better. If the model is closed, like GPT-4, you can't touch it. The engine is sealed.
So you'd have to build your own entire GPT-4 from scratch.
From the ground up, just to test your one little tweak on the embeddings.
Which would cost, what, $100 million in compute time?
At least. It's impossible for a researcher or a small startup. And Wolf's point is that these open models represent a distillation of hundreds of millions of GPU hours. That is a massive amount of energy, money, and time.
So open source lets you stand on that mountain of compute and just change the one piece you're interested in.
It's like trying to modify a car engine. If the hood is welding shut by the manufacturer, you can't just go in and install a turbocharger.
You have to build a whole new car.
Precisely. And because the hood is open at Hugging Face, you get all this innovation that the original creators never even intended. He brought up interactive world models in gaming.
Oh, this was the example that really clicked for me. Walk us through that.
So an image generation model is typically static. You type cat on a bike, it gives you a picture of a cat on a bike. End of story.
Good.
But someone in the community took a pre-trained image model, something just meant to make static pictures, and they hacked it. They added an interactivity component.
So they actually changed the code so the image could react to input.
Yes. And suddenly, you have a generative AI video game engine. You can move the cat.
Yeah.
The world updates around it. This was not on the roadmap for the people who built the model.
And if that user had just been using a closed API, they would have been totally blocked.
They would have been limited to whatever the API allows.
Yeah.
You know, if you want to use ChatGPT for some weird, hyper-specific, domain-specific language, a DSL that wasn't in its training data, you're just out of luck.
You can't force it to learn.
You can't. But with open source, you can look under the hood, you can retrain those layers, and suddenly it works for your niche.
So distributing the tools leads to innovation the toolmaker couldn't have predicted. That's the catalyzing effect. But, and this is the big but for everyone listening who's thinking of building an AI startup, Wolf also drops a hammer on what he calls the demo trap.
This is so crucial. We see it all the time on social media. Someone posts a video, look, I built a customer service bot in 5 minutes using this open source model.
And it looks incredible. It answers 3 questions perfectly. The video goes viral.
It looks amazing as a demo, but Wolf says the gap between that demo and an actual product is massive. He calls it a canyon, and he uses the term scaffolding.
Scaffolding. Unpack that. What are we actually building when we build an AI product?
Okay, think of the AI model as just the raw engine block. It's got power, it's got huge potential, but it has no transmission, no brakes, no steering wheel.
No chassis.
Nothing. The scaffolding is everything you have to build around it to actually make it usable for a human being.
And what does that look like in code?
It's the pre-processing of data, so the model even understands the input. It's the guardrails to stop it from hallucinating or saying something offensive.
It's latency management, making sure the user isn't waiting 30 seconds for an answer.
Handling all the edge cases where the model just completely fails.
So the AI is maybe 10% of the code, and the scaffolding is?
The other 90%.
The other 90%. Often, yeah. And Wolf says there's basically never a case where you take a model out of the box and it just works in production. You always have to build the scaffolding. That's the real work.
Which leads to that big decision every startup faces, fine-tuning.
Right. Fine-tuning feels like the buzzword of 2025. Everyone wants to take a llama model or a Mistral model and just, fine-tune it on their company data. It feels like the thing you're supposed to do.
And Wolf warns that this is non-trivial. It's not just pressing a button. It requires real expertise.
You have to clean the data, set the hyperparameters, monitor for drift.
Right. And he puts it this way. If you are a 3-person startup, you have to ask yourself, is fine-tuning the model our core value proposition?
So if I'm building, say, a generic email writer, probably not.
Probably not. But if you're building that interactive world model we talked about, something that literally doesn't exist yet inside the model's brain, then yes, You must fine-tune. You have to change the brain of the model.
But if you're just trying to make the model sound a little more professional for your use case.
Maybe you don't need to burn thousands of dollars on training runs. Maybe you just need better prompting and better scaffolding.
I loved his perspective on this, though, on the difficulty. He didn't say it's hard, so don't do it. He actually flipped it. He said the pain is the point.
That was such a profound insight. He argues that the difficulty of the process building, that complex scaffolding, figuring out the fine-tuning, that is your moat.
Because if it were easy.
If it were easy, everyone would do it. If you could just download a model and have a perfect product in 5 minutes, you don't have a business. The pain of that integration is what makes your product valuable.
It's what makes it defensible against the next person who comes along.
That is a message for the founders right there. Embrace the suck, because that's your business model.
So I want to shift gears a bit to how Wolf views his own role. He's the chief science officer, but when he talks about the Hugging Face libraries, he sounds a lot more like a product manager at Apple.
It's true. He explicitly said that when he was building the first libraries, he saw himself as a chief product officer for the open source community. And he makes a great point. Open source users, developers, are the hardest clients in the world to please.
Why? Because they're smart. Cynical.
Both, but mostly because the product is free and the switching costs are incredibly low. If a developer downloads your library, tries to run it, and gets some cryptic error message in the first 5 minutes, what do?
They delete it, they go to GitHub and find the next repo immediately.
Exactly. There's no contract, there's no sunk cost. So you have to win them over with just pure design and usability.
And he has this concept he calls the unboxing experience.
Yes, which is a term you usually hear for luxury goods, right?
Huh?
Phones, expensive gadgets, not for Python scripts.
Right. Usually unboxing a library means reading a README file that hasn't been updated in 3 years.
Yeah, exactly. But he treats it like a luxury product.
Yeah.
He tracks a very specific metric. The distance from pip install to running a non-trivial example.
Not just hello world.
No, hello world is too easy. He wants you to run something that makes you go, wow, something useful. And that distance, he says, needs to be short and delightful. He has this golden rule. No user wants to read the documentation.
Amen to that. If I have to read a 20-page manual just to get something to run, I'm already annoyed. I want to learn by doing.
He believes the tool has to be obvious. And to achieve that, he uses this mental technique that I think is applicable to anyone building anything. Before a release, he constantly resets his mind to a fresh state.
How does he do that?
He literally wipes his environment, deletes everything, and he reinstalls his own library from scratch to see if it feels intuitive to someone who has never seen it before. He tries to forget that he wrote the code.
That is so hard to do when you're the one who built it. You know all the weird quirks. You know where the bodies are buried.
It's the curse of knowledge.
Yeah.
You unconsciously skip steps because you just know how it works. But fighting that curse is what makes their tool so popular. They assume the user knows nothing about the internal complexity.
And this leads to his second big design principle, the abstraction cursor.
Right. This sounds a bit technical, but I think the concept is crucial for anyone building tools.
Explain the cursor.
Imagine a slider. On the far left, you have ease of use. On the far right, you have control and complexity.
Okay.
If you slide that cursor all the way to ease of use, you hide everything. It's a black box. You press a button, magic happens.
Which is great until I need to change how the magic works.
Exactly. Then you're stuck. You've hit a wall. But if you slide it all the way to control, you're just giving the user raw code. It's powerful, sure, you can do anything, but they have to spend weeks learning how to even use it.
So a good library isn't just about being easy, it's about finding that sweet spot.
Wolf says a good library has to be opinionated. You have to choose where that cursor sits. You have to say, we think this is the right level of abstraction for 90% of our users.
Too much abstraction creates friction because the user has to learn your specific way of thinking.
And too little offers no help. So you have to be, as he says, design opinionated. You have to make a choice. And that choice determines if your tool gets adopted or just ignored.
I want to zoom out now. We're looking at this recording from late 2024, early 2025. What does Wolf say is the outlook for AI innovation?
He addresses the elephant in the room.
Mm-hmm.
The gap between the open source models and the giant closed proprietary ones like GPT-5 or Gemini.
And the narrative has always been that open source will lag, right?
Right.
By 6 months, maybe a year. They just don't have the compute to keep up.
And Wolf says that narrative is basically collapsing. He pointed to some specific models making waves at the start of 2025. He mentioned DeepSeek and Kimi.
DeepSeek has been everywhere lately.
Right. And he notes that these open, or at least, accessible models are practically state-of-the-art. The gap is closing incredibly fast.
So the difference between the model you pay $20 a month for and the model you can download for free is becoming negligible.
It's trending that way.
Yeah.
So the question becomes, if the models are all basically equal, if I can get a state-of-the-art model for free, where's the value? How do companies make money if the intelligence itself is a commodity?
And this is what he called the awesome news for founders.
This is the awesome news. As the models commoditize, the value shifts up the stack. Can the application layer, the interaction layer.
It goes right back to the interface.
Look at ChatGPT. Its success wasn't just that the model was good, it was that the friction was zero. It was a chat box. My grandmother could use it. Wolf argues startups don't need to train massive models to win anymore.
You don't need to be a core AI researcher.
Yeah, you don't. The real opportunity is in building the stack on top of these powerful free models.
That scaffolding we were talking about earlier.
The scaffolding, the interface, the specific workflow that solves a real human problem. That is where the money is going to be made in 2026 and beyond.
That's empowering, really. It means you don't need $1 billion in compute clusters to compete. You just need a better idea for how humans can interact with the intelligence.
Precisely. The barrier to entry for intelligence has gone way down, but the bar for product quality has gone way, way up. Because when the intelligence is free, the experience has to be premium.
So let's bring this all together. We've gone from laser fusion to the unboxing of code libraries. What are the big takeaways for you?
I think it comes down to three things. First, the power of interdisciplinary thinking. That physics rigor meeting the lawyer's efficiency. You need both to build a unicorn.
You need to explore, but you also need to ship. Check.
Second, the reality that scaffolding and pain are the actual moats. Don't fear the hard work of integration. That's the only reason anyone will pay you. If you're just a thin wrapper around a model, you're dead.
And third,
the user-centric design of tools. Even if you're building for the smartest engineers in the world, you have to treat them like consumers unboxing a new gadget. Respect their time. Make the abstraction intuitive.
that unboxing analogy is really going to stick with me. It's such a high bar for something so technical, but it makes perfect sense. And it brings me to a final thought. Thomas Wolfe talks about making libraries so intuitive that you never have to read the documentation.
The code just explains itself. The tool is obvious.
Right. And it makes me wonder, if the smartest tools are designed so we don't have to learn them in the traditional sense, what does that say about the future of how we learn to build software? Are we moving toward a world where the code explains itself, or are we moving toward a world where we just stop understanding the tools we use because the abstraction is just so good?
That is the question. When the abstraction is perfect, do we become masters of the tool, or do we just become passengers along for the ride?
Something to chew on while you're debugging your next project. That's it for this deep dive into the architecture of open science. Thanks for listening.
See you next time.